we're going to look at what's called maximizing area in lesson 107. And I'm just going to go through the example and then show you what we are proving kind of in the end. Okay, we want to see which shape has the biggest area. And so in example 1, it gives us a rectangle QRST. And it says h is the height, b is the base. And it wants to know if your perimeter is 24. Okay, perimeter is 24. Determine the area if the base is 2, if the base is 4, if the base is 6, and the base is 8. Well, basically the perimeter formula would be 2 times base plus 2 times h. Yes? So, and we're determining the area. So we already know the P, the perimeter, is 24. So now let's solve for each of these, okay? The first one, it says base is 2, so we're going to plug that in here. Okay? So 2 times 2, that'd be 4, plus 2h equals 24. Subtract 4, 20 equals 2h, so your height would equal 10. So I'm going to write down here that when the base is 2, the height equals 10. I'm going to write what corresponds underneath. I'm going to spread these out just a little bit. So we're going to write what corresponds underneath. So when the base is 2, the height has to be 10, because that'd be 4 plus 20, giving us 24. So now let's do the next one. We'll determine the area in the end. I know we're overall supposed to determine the area, but we'll do that after we get through all this. So now, if my base, remember this is base, is 4. Let's see what the height is. So that'd be 8 plus 2h equals 24. Subtract 8, that's 16 equals 2h. So h would be 8. You're probably catching the idea that that's going to be 6, that's going to be 4. And it is going by 2s. So I'm going to erase this now. All right, so hopefully you understand. I just fast forwarded there, and hopefully we understand the math. Now I want to determine the areas of each of these. So the first one, 2 times 10, that would be 20. The second area would be 32, 4 times 8. The third area would be 36. The fourth area would be 32. So these are each of the areas. Now let's get to the point. The point would be, notice all these had the same perimeter. But the point that they're trying to make is the more that the sides are the same, the bigger the area is. So 2 and 10, those are not as close together as 8 and 4. Notice my area for 8 and 4, my sides are closer together. My area is bigger. What it really wants you to know is when it's a regular polygon, so when it's 6 by 6, regular polygon or a square, that area will be the biggest. Okay, so area of regular polygon is largest. That is, once again, when you have perimeters that are all the same. And that is the point of maximizing area. Okay, that's what they're trying to prove. Example 2 wants to know if all these shapes, okay, if all these shapes have the same perimeter. I'm not going to do the whole thing, but I just want to tell you what they're trying to prove. But if all these shapes have the same perimeter, say they're all a perimeter of 30. In the end, just know that the more sides there are, the bigger the area when the perimeter is the same. So the perimeter here is 30, okay, for all these or whatever. Just know that the perimeter will increase the more sides you have. So, which of these three has the biggest area? I think I said perimeter earlier. Which of these three has the biggest area? This one would have the biggest, okay? Area. Because it has the most number of sides. That's all it's trying to prove to you in example 2, so we're not going to do the math. If you want to see that, you can look in example 2 more in detail, but that is the proof behind the problem. So that's all there is to maximizing area, not much math, just kind of more proving different scenarios.